All right, so after a short break, we're back at it. The Physics Unit 3 study guide. This is part 2. We're going to be focusing on those forces in two-dimension questions on the third and fourth page. So starting here, it says calculate all the forces, including the net force of a 50 kilogram box at rest on a 20-degree slope. So I like to start these problems by drawing a picture. Makes it easiest for me. I got a slope here. My slope is 20 degrees. I got a box, 50 kilos in it. And I got to think of all my forces acting on this. Always start thinking about gravity. So you got gravity pulling straight down. That's your force of gravity. You have the normal force. And your normal force is going to be perpendicular to your plane, or your slope in this case, going in this direction. So that's your normal force. And if we only had those two forces, that box would be moving to the right. So there is another force. We know this box is at rest. And because it's at rest, that means our F net equals 0. There we already got one of our forces, F net, net force. And the reason that has to be is we have friction holding this box in place. So friction is pulling that box this way. So now it helps to draw a free body diagram based off of this. When you have a slope question, you could just draw your free body diagram like this, but I don't recommend it. I recommend tilting your frame of reference and your coordinate system so that your normal force goes straight up, and that means your friction force is straight back. So now our free body diagram, and we'll draw our y and our x, and our normal force straight up, and our friction straight off to the left. And what you got to think is, how much did I have to tilt my paper to get this flat? And it turns out it's going to be 20 degrees. So our gravity is going to be 20 degrees. This is kind of imaginary. The gravity is 20 degrees, or whatever the slope is right here, off on the side. So our gravity will be going off this direction. And that'll be 20 degrees. FG. All right, so now we got to start calculating some of our forces. And all we know, well, we know our slope, and we put that there, but all we know is this box is 50 kilograms. So when you know your box is 50 kilograms, I would go straight to your force of gravity. We can calculate that force because force of gravity is your mass, 50 kilograms, times the acceleration from Earth, 9.8 meters per second squared. Multiply them, and we get your force of gravity. Just so we know, I'm going to use all positive numbers here, but when we're looking at the down direction, those are, we got to think of them as being negative, and when we're looking up, those would be positive. And when we have a net force, they'd have to cancel out. So here our magnitude of our force from gravity would be 9.8 times 50, or exactly 490 newtons. Now that is going to help me get my components. I need to get both my y component, that's going to be this right here, FGY, and I need to get my x component right here. And I'm just going to solve for those right on the side here. FGY is going to equal the magnitude, 490, and this is going to be cosine because it's right adjacent to that, 20 degrees. 490 cosine of 20, and that is going to be, I'm going to round it to 460 newtons. Force of gravity in your x direction is going to be 490 sine 490 sine of 20. And let's take a look at what that is. 490 sine 20, that is about 168 newtons. I'm rounding to the nearest whole numbers to make the math a little bit easier. And it's all right if you do that too, unless your teacher says don't. All right, so we got a lot of information here. We know our net forces have to cancel out. So this is what I'm going to be using to do my next steps. In my vertical direction, my F net Y, that would be my two vertical forces. Here, I could write it out. F net Y equals 0. And it's going to be the normal force plus, or because this is in the negative direction, here, we'll put a negative here, R, gravity in the Y direction. Or we could rewrite this because this equals 0. The normal force is equal to negative of your gravity. So our normal force equals 460 newtons then. And we're going to be doing the same exact thing to our friction. This box is at rest. That means the F net in your x direction equals 0 would be FGX, which is a positive number, plus your friction, which is a negative number, or, your friction equals negative FGX. So our friction then would equal negative 168 newtons. Don't worry too much about your signs. As long as you know your magnitude's 168 and your direction's in the backwards direction, then you got it. All right, so next question we got, a 40 kilogram kid is sliding down a slide at 50-degree angle. That's a pretty steep slide. And that kid has a net acceleration. So I'm going to start just by calculating my net acceleration. I just got so excited for it. Remember, force is equal to mass, and so the net force would equal mass times your net acceleration. So F net in this case is going to equal 40 kilograms times 2 meters per second squared, or 80 newtons. That kid is flying. All right, so let's draw a picture of what this looks like because we have to calculate all the forces. 50 is pretty steep. Look at this kid. 50 degrees, 40 kilos. And again, we're going to notice a pattern. Same forces. Gravity. Up this way, normal. Back this way, friction. In this case, the friction is not as strong as the gravity pulling it forward because there is a forward acceleration. So let's take a look at what that means as we jump into this question. As I draw this free body diagram, I'm tilting it again so that my normal force goes straight up and my friction goes back, and my gravity is going to appear to go forward. That is the force dragging that kid down the slide. So normal force, friction, and gravity pulling the kid down the slide at a 50-degree angle. And again, just like the last question, first thing I'm going to do, well, after finding my net and drawing my free body, I'm solving for my gravity. 40 kilos times 9.8 meters per second squared. Our force from gravity equals 392 newtons. Next thing I'm going to do, break down my gravity components. All right, we got here FGY, and we got here FGX. Again, FGY, because it is our adjacent side, FGY equals 392. That's going to be a cosine of 50 degrees. 392 cosine 50 gives us 252 newtons. It is in the downward direction, so we'll put a negative there. And I'm going to I'm gonna pause here. I know I could keep going. I could find my force of gravity X, but I want to remind us that we have everything we need to find our normal force. Just like up here, our F net Y equals 0. This is our F net X, because that kid is not flying up from the slide. That kid is not going through the slide. The F net Y equals 0. So this negative 252 needs to cancel out with your 252 from your normal force to equal 0. So this is actually the normal force. We've now got our normal force. And we could add here that this is actually all in the X direction. All right, so now to find force of gravity in your X direction. Again, 392 is the magnitude of the gravity. This is our opposite side. Sine is opposite, sine of 50 degrees. Let's see, 392 sine 50 degrees. We're gonna round that straight to 300. What a nice number. That is in the positive direction. So this is where we gotta think. If we add all our horizontal forces together, we should get 80 in the positive direction. Remember that kid is going this way. That's the direction of our net force. So we'll write this down. Net X equals all of my X forces added up plus friction. F net is 80. My X for my gravity is 300, which means in order for 300 plus my force of friction to equal 80, I subtract 300 from both sides, and I get my force of friction is negative 220 newtons. Or we could think of it as 220 newtons in the negative direction. And look at that, we got it. Question 10. This is based off of that. Calculate your coefficient of kinetic friction. Remember, we have friction equals coefficient of kinetic friction times your normal force. Plug and chug. Friction, we're going to use the magnitude, just the magnitudes of these forces. 220 equals coefficient of kinetic friction times 252. Technically, we should have our units there, but because they're both newtons, they cancel out. You divide both sides by 252, and you get your coefficient of kinetic friction is equal to 220 divided by 252, about 0.87. No units on that one. All right, look at the progress we're making. Give yourself a pat on the back. We're going to the back page where we got 3 more questions. And we got another sliding question here. This is a much larger kid, 60 kilograms, but he's sliding down a less steep slide. Thank goodness. That could get dangerous. 30 degrees, 60 kilogram kid. We'll put his mass in his head. All right, there he goes. He's going down the slide. He's got a coefficient of static friction of 0.45. You guys, I made a typo on this one. This kid is sliding. That has to be a kinetic friction. All right. Calculate all the forces, including that net force. In this case, that net force will probably be last. Remember I said these questions can feel very different. When you're ever stuck, free body diagram that. We know there's gravity. We know there's a perpendicular normal force. We know there's friction. And that's it. Tilt it. Normal force is going straight up, friction going back. You have your gravity now popping forward 30 degrees. Normal force. gravity 30 degrees, friction. All right, let's work this out. We know some things. We know how to find gravity. We know the mass is 60 kilograms. We know Earth accelerates at 9.8 meters per second squared. Multiply those together. 588 newtons. Look at us, we're flying. Now that we have this, let's find our components of gravity. We can break this down. That's our vertical component, FGY. There's our horizontal component, FGX. We know our degrees are 30. Y is going to be the adjacent here. So over here, we're going to be working FGY equals 588 cosine 30 degrees. Let's plug that in. 588 cosine 30 gives us about 509 newtons. That's going to be in the negative direction. What that tells us, though, is that our normal force, and again, I'm not going to be, well, just similarly to how we did our last few problems, our vertical forces have to cancel out because this kid is not flying out. He's not bouncing off the slide. He's not falling into the slide. Our vertical forces cancel out. So our normal force is 509 newtons. Next, we got to calculate our force of friction. This is where we got to think, this question's a little bit different. They gave us a coefficient of friction, and we know that friction times our coefficient of friction, friction equals the coefficient of friction times your normal force. Look at that, we calculated our normal force. So from here, the force of friction equals 0.45 times 509 times 0.45. We are going to round this to force of friction equals 229 newtons. It is in the negative direction. I will add a negative there. What's important is we know the magnitude is 229. Lastly, we got to get our net force in the y direction. And this is tough. Because we know there's two horizontal forces. We got friction here, we got FGX here. Let's solve for FGX so we know exactly what it is. That is the opposite side. So it's 588 from our magnitude of gravity. Sine 30 degrees. Plug this in. 294 newtons. All right, so remember, F net of x is what you get when you add all your horizontal forces. That's going to be FGX in this case and our friction, or 294 newtons for FGX right here, plus negative 229 newtons from our friction. So F net x, look at us. 294 minus 229, 65 newtons. All right, so in the next question, we know this kid is having a net force of 600, or sorry, not 600, that'd be a lot, 65 newtons. We can remember that force equals mass times acceleration. This question is asking us to calculate the net acceleration, so we just plug in the force, 65 equals the mass, 60, let me put units here, 60 kilograms, times our acceleration. Acceleration, divide both sides by 60, equals about 1.08 meters per second squared. So a little bit over 1 meter per second squared. Acceleration doesn't sound like a lot, but depending how long that slide is, that kid could be going pretty fast at the end. All right, last question. Then we're taking a break. 2 ropes are pulling a 40 kilogram box. The first rope is pulling with a force of 200 newtons at a 30-degree angle. The second rope is pulling with a force of 346.4 newtons at a 120-degree angle. Calculate the net force on the box. All right. Well, let's do this. We got here is our box. We are going to kind of draw this 0 angle dotted line just to show where 0 is. The first rope is 200 newtons at 30 degrees. Okay. Force tension 1 equals 200 newtons. Our angle is 30 degrees. Second rope is 120 degrees, so that's way up here. Force tension 2 equals 346.4 newtons. 120 degrees. And then, of course, gravity, always gravity. And you know, we're just going to jump ahead and calculate gravity. Gravity is going to be the mass 40 kilogram box times our acceleration of gravity, 9.8 meters per second squared. Our force from gravity equals 40 times 9.8. And the great thing is, this is not on a slope. There is only a y component, 392 newtons. Feeling good about that. The other thing we can do is, well, I guess the other thing we have to do, well, if you wanted to, I'm not going to solve it this way. If you wanted to, you could notice that there's a 90-degree difference here, and you could turn it this way, and you could solve it that way. I'm not going to do it that way. I'm just going to use this as my free body diagram, and we are going to break this down into components, both sides. We got ft1y over here, ft1x. ft1y is going to be 200 sine of 30 degrees, and ft1x is going to be 200 cosine of 30 degrees. And let's get both those numbers right now. 200 sine 30, exactly 100 newtons. And this force right here, 200 cosine 30, is moving right at about 173.2. We'll round to 173 newtons to the right. All right, now we got to break our other one down into components. Remember, there's a couple ways to do it. You can use this angle right here. This would be 60. I am not going to do it that way. What I'm going to do is, because they give me this really great angle right here, 120, I'm going to remember that cosine refers to my x-axis. So this would be 346.4 cosine of 120. 346.4 cosine 120. That would give me negative 173 newtons. And vertically, I would be plugging in 346.4 sine of 120. 346.4 sine 120. That would give me a perfect 300 newtons. Now take a look at this. The F net in our x direction. A negative 173 here from this rope, positive 170 from that rope. 0 newtons in my x direction. This rope, this box here is not swaying side to side. It is getting pulled in the vertical direction. Lastly, we are going to take a look at F net y. That is going to equal force of tension 1 in the y direction plus force of rope 2, tension 2 in the y direction plus force of gravity. All right, let's finish this one up strong. Force of tension 1 in the y direction was 100 newtons right there. 100 newtons. Force of tension 2, 300 newtons up. Gravity plus, we got a negative number here because remember gravity is pulling us down. Negative 392 newtons. Add them all together, and this box is being pulled with 8 newtons of force up. I could ask us similarly to find a net acceleration using an equation like that, but I think if you're understanding this, you should feel super solid for this test. And just remember, it takes practice. It's never easy the first time. It just takes time and hard work.